Hello and welcome to the Section 4.2 lecture today for Algebra 1 Part 2. Today we're going to be talking about surface area and volume of cylinders. So again, we're looking at some geometry measurements and geometry measurements sort of in different dimensions. Because remember, surface area is going to be a squared area. Actually, I'm going to say just a squared measurement. Of the outside of a figure. While volume will be a cubed measurement. Of the space inside a figure. Okay, and the main thing that I want us to remember is that surface area is squared, volume is cubed. Let's do the same thing we did yesterday and decompose this solid into its net. I'm going to use some kind of cheaty little tools here. So if I again fold the circles out, because we have circles today. If I fold those circles out, they don't have to be to scale, but I'm going to try to do them as good as possible. I need two of those. And in the middle, sorry, will be this rectangle. Okay, so in the middle we'll have this rectangle. And we'll try to do it as good as we can. I'm actually going to drag that a little bit more to, maybe not. Maybe not. We'll just move the circle. That's kind of the cheater way to do that. So I'm really trying to make those two line up at the very top of this circle and the very bottom of this circle. Okay, that's kind of my goal. So some things that we know, some measurements that we know on here. We know that our radius on the circles are 10. And what else do we know? We know that on the side here, this kind of curved side that goes around, we know that this measurement is totally not to scale, but I would say that this measurement right here is 19. Okay. And then the concern is, what is this measurement? How am I going to find this distance? Well, to kind of break that down a little bit, realize that we actually have a shape that meets the definition for a prism. Okay, and if we're looking at a prism, and again we look at surface area of a prism that we talked about yesterday, it's 2 times the base plus that lateral area that yesterday we said was the perimeter times the height of the prism. And again, a prism just means that the two bases, the top and the bottom, are the same exact shape. Okay, they're congruent shapes. So this is just that. It's no more than a prism. That's just what it is. And so we're going to use that idea. But we have some special formulas that we're going to use when we're starting to talk about this being a cylinder. Okay. And really the special formulas just come from the fact that we're dealing with perimeter of a circle and area of a circle. So for a cylinder, the base is a circle. So the area of the base is going to be pi r squared. And then perimeter of the base is going to be 2 pi r, because that's what perimeter of a circle is, or circumference of a circle. So we have 2 pi r, and then times that height. Now there is a little simplifying that we can do, and it's kind of up to you. If you want to think of it with this formula, that's perfectly fine. But if I look at having 2 pi r squared plus 2 pi r times h, I can actually simplify that a little bit by pulling out a 2 pi r from both of these. Right? If I think of this r squared as just r times r, then I see that both of these terms have a 2 pi r in them. They both have a 2 pi r. So this is kind of like combining like terms, but doing it with variables and pi, which we're kind of looking at as a variable, but then we realize it's just a number. So the way we would pull that out is we would say that there's 2 pi r, and then in parentheses I'm going to let there be r plus h, being the two things that I've pulled the 2 pi r out of. You'll notice if you distribute all this stuff back in, you will end up with this same 2 pi r squared plus 2 pi r h. If you want to use this one up here, you're more than welcome to. This one's a little bit quicker. So I definitely encourage you to use that one. Okay, so let's use that formula, and we definitely want to have that down. But let's use that formula today to find our surface area. So if I'm looking for surface area, I'm looking for 2 pi r times r plus h. Let's put the numbers that we have in where they need to go. 2 pi times, wrong one, I'm going to say 10. 2 pi times 2 times 2 plus 10. Well, that turns out to be 2 pi times 2 times 12. So 2 times 2 is 4. 4 times 12 is 48 times pi. I suppose I will need a calculator today. So I'm going to put that here, with that there. It's not going to want to let me do this, so let me try this again. There it is. We'll go with that. So this turns out to be 48 times pi. We'll use 3.14, and we get 150.72 meters squared. Again, surface area is a squared measurement. Okay, let's look at the next one. I have a height of 7 and a diameter of 14. So one thing that you should probably do for yourself is to turn your diameter into a radius by cutting it in half. Cutting it in half gives me 12. So my surface area, I'm going to go right to plugging in numbers. 2 pi times the radius, and then the radius plus the height. That's going to be 19, and this will be 24 pi times 19. I'm just going to use a calculator for that. 24 times 19 times 3.14. Pretty big number. And again, those are square meters. Okay, same thing on this next one. I have a diameter. I want to turn that into a radius. So that's going to be a radius of 12. And we have a height of 9. So our surface area, 2 pi times the radius. Oops. Made that mistake again. I used the wrong number. 2 pi times 12. And then 12 plus 9. So this time we have 24 pi times 21. So an even bigger number. We have 1582.56. And those are square yards. Next one. Looking for surface area. 2 pi times the radius. I do have a radius this time, so I don't need to cut it in half. And then the radius plus the height. 2 times 6 is 12. And that's going to be 12 pi times 9. You get 339.12 yards squared. Okay, let's move on. For volume, again, we're dealing with the same 4 problems. I'm trying to do that for consistency. But for volume, again, it's a prism. And so if we look for volume, in a prism, the volume of a prism is the area of the base times the height. Since we're dealing with circle bases, we can put that in. Pi r squared times the height. So here we can look at those. If we take pi, the radius is 2 squared times 10. 2 squared is 4. 4 times 10 is 40. So we have 40 times pi. And so we get 125.6, and those are going to be cubic meters. Okay, volume is a cubed measurement because it's counting how many squares, how many 1 by 1 square, 1 by 1 by 1 squares will fit inside. The next one, again, I've got that diameter instead of the radius that I want, so that radius is going to be 12. So we're going to have pi times 12 squared times 7. The easy one, 12 squared, is 144. I don't know what that is times 7. Turns out to be 1008. But then when we multiply it by 3.14, we get 3165.12. And those are meters cubed. Sorry about that. Okay, next one. Same adjustment we have to make. We do have to know the radius is 12 from a diameter of 24. So we have volume equals pi times 12 squared times 9 as the height. Again, even though this height is going horizontally, it's still a height because it's the distance between my two bases. And we'll just do all that on a calculator. 12 times 12 is 24, times 9 times 3.14. 4,069.44. And those are cubic yards. Last one we already have the radius, so I'll use it. Pi times 6 squared times 3. If you don't know what any of the squareds are, you can just multiply the number by itself. But it is 36, and we get 339.12. It almost feels like it's the same answer. And I just want to double check, was it? It was. So if you can tell me why that ends up being the same answer, that would be a good exercise for you. Okay? Anyways, that'll be it for today. Make sure you put any questions you have over on the left. Otherwise, have a great day, and we will see you in class.